Hi guys and ladies, and welcome back to my channel XYZ Architect. I'm Marius, and today we are going to talk about geometrical elements and how to measure them. So stay tuned and find out all about this next. Every CMM programmer or application engineer has to wonder, how many points do I have to take on this element in order to be safe? Well, according to the quality of the part, its destination, and the time that you have to allocate to measure the part, you have to estimate the number of points necessary to measure the element. Rules to establish the number of points. So the number of points has to be distributed regularly on the element. The number of points grows if we have a wide element. The number of points grows if we have a tolerance, a low level tolerance. And again, the number of points grows if we have a low quality part. Now, keep in mind that a large number of points taken on the element doesn't do any harm, but it will cost you a lot of time. Okay, so we have some more rules regarding the points. As you see here, I have put together a table with the number of points for measurement, the type of the element, the minimum mathematical number of points recommended to define the element, and the recommended number of points. Okay, so let's take the first element, the line. We have to take 2 points, to touch 2 points on the part to define a line, but it's recommended to use 5 points. For the plane, we will have to use 3 points to define the plane, but it's recommended to use 9 points, at least 3 lines and 3 points on the line. Okay, so for the plane, you probably know that if you use 3 points to make a plane, you will have a plane with no form deviation. So each time the form deviation of the plane, if you use 3 points, it will be 0. So keep this in mind. You will need to do at least 4 points to see if you have a deformation on the plane. So if you want to evaluate the flatness of the plane, do not use a plane with 3 points. It will be 0. The deviation will be 0. Okay, let's move on. The circle, you will need to have 3 points, to touch 3 points on the element to define the circle, but it's recommended to use 7 points. It's recommended to use 7 points because you have to detect the lobes. So if the form of the circle is like this, for example, these are the lobes, and if you want to touch them and to detect the form of the circle, you will have to use 7 points. Okay. And of course, the center of the circle will be moved if you take least points. Okay, so for the sphere, you will have to take 4 points to define it. It's recommended to take 9 points. At least 3 sections formed from 3 circles with 3 points. For the cone is enough to take 6 points to define it. But it's recommended to use 12 to 15 points. You will have to make 4 parallel sections formed from circles to use information for the straightness, if you want to use straightness information for the cone, and 5 points on each circle to see the roundness information. For the ellipse, you will have to take 4 points to define it, the minimum mathematical number, and 12 points is the number of points recommended to make the ellipse, and also more points if you want to detect the form deviation of the ellipse. For the cylinder, it's enough to use 5 points to define it. Actually enough. It's the minimum mathematical number is 5. So if you take less than 5, you will the software will not know how to evaluate the cylinder. It will not know that you want to tell it that there is a cylinder there. Okay, then 12 to 15 points is the number of points recommended. Again, it's 4 parallel sections formed from circles for straightness information and 5 points on each circle for roundness information. And for the cube, it's 6 points to define it and 18 points recommended, at least 3 points on each face of the cube. Okay, so this is the model that I created in order to explain better the points necessary to take for the elements. As you see, we have a lot of elements here. We have planes, we have slots, we have cylinders, we have ellipse, we have cones, spheres, and so on. And I also created technical drawing of the part, and as you see, we have here a lot of dimensions. We have dimensions for the slot, we have dimensions for the sphere, the radius of the sphere, the diameter of the sphere. We have true positions according to datums, true positions according to pattern with polar coordinate system, theoretical distances. This is about this we were going to talk in another video. We have dimensions for the ellipse, dimensions, for example, for the 4 cubes from the back side right here, and the datums, as I said. Okay, the height of the cylinder right there, and so on. Okay, so regarding the measurement of the slot, you will have to make, for the slot and for the ellipse as well, you will have to make minimum number of points just to locate the element. Okay, so this is just for the slot. You can do it also for a circle, for a cylinder. It is recommended if you want to measure the part very precisely, but for these particular elements you will need to do it every time. Why? Because you will see that when machining, the slot can be exaggerated, like this, for example, right? So it's very inclined. So when you take the points, you will get the X and the Y axis, and you will see that you will find the element exactly as it is, and then you make an alignment, for example, or use a formula to take the center of the slot and use the X and the Y axis to make it again, and you will see that the machine will know exactly how to go and to find your element. As I said, for the ellipse it's also the same. You can find the technical drawing of the part and the example that I put together in a table in the description below. So everyone, that's it for today. I know that some time has passed since my last video, like 2 weeks, but I did had to take some time to gather the information that I put together in this video. So if you like what you saw today, please smash that like button, share and subscribe. See you next time.